हेलो गाइस, वेलकम टू दिस वीडियो। ये वीडियो है कॉन्सेप्ट्स के पार्ट 8 के बारे में, जो कि होगा न्यूटन्स के सेकंड लॉ और लीनियर मोमेंटम के बारे में। ठीक है, चलो शुरू करते हैं। लीनियर मोमेंटम एंड न्यूटन सेकंड लॉ ऑफ मोशन। ठीक है, व्हाट इज लीनियर मोमेंटम? मोमेंटम क्या है? एक इंसेंटिव। ठीक है, मतलब आप कुछ अच्छा कर रहे हो तो फिर आपको ऐसा बोला जाएगा कि आपका मोमेंटम बहुत अच्छा है। Means if you're a cricketer and if you're scoring runs, plenty of runs, means you have scored in the last two matches, you have scored 200s, then it will be said that this batsman's momentum is on sky high, its momentum is going on. If you are a cricket team and you are losing, means you are winning matches, then it will be said that your cricket team's momentum is good, so that they are winning. So momentum is nothing but an incentive. Okay, means the extra force, means not extra force, not word, the extra energy that you get, okay, to do some work, that will can be said as momentum. Okay, linear momentum is what the okay, thus the force needed to stop a moving object, okay, in a definite time depends on both the mass and its velocity. Okay, linear momentum is what? Linear momentum of a body is the product of its mass and velocity. Okay, linear momentum is what? The product of mass and velocity. So it is denoted by small p, and word momentum is used for linear momentum. For a body of mass m with velocity uh, v and linear momentum p is equal to mv. Okay, remember it. It is a very useful formula. It is a vector quantity. As you can know, also velocity is a vector quantity. So if mass is scalar quantity, but whenever you multiply anything with vector quantity, that will become a vector quantity. Okay. So a vector quantity in the direction of motion of the body, that is along the velocity. So the direction of velocity will give you the direction of linear momentum. Okay. From relation P is equal to mv, unit of momentum is equal to unit of mass, that is kg, unit of velocity, that is meter per second. Okay. So that would be SI momentum is SI unit would be kg meter per second, and CGS unit would be gram centimeter per second. Okay. Got the idea of linear momentum? Okay. Next is what? Change in momentum. As you know the formula, P is equal to m into v. Okay, similarly we can use del P is equal to del m into v, where del is commonly called as delta, or it is just means to say that there is something change, we use delta. Delta P is nothing but the P final minus P initial. Okay, that we denote by using the symbol delta. The change in the product, uh, change in the product of the mass be product of momentum be either to the change in mass or due to change in velocity. Okay, the change in product can be either due to change in mass or change in velocity. If both of them are changing, then there will change, and if there is also one changing, then also it will change the product. Okay, if mass remains constant, then the change in momentum is due to the change in velocity. Okay, if mass is remaining constant, then del P is equal to m into del V. Okay, in case of atomic particles moving with velocity comparable to light c, that is 3 into 10 to the power 8 meter per second, it is observed that the mass of the particle remains constant, but it increases according to relation m equal to m naught 1 minus v by c square. Okay, that is a relativity formula, where m naught is the mass of the particle when it is at rest. M naught is known as the rest mass. Okay, in such a case we can write del mv is equal to m into del v, and del P is equal to m del V is true only if velocity, okay, if okay, the relation del P equal to m del V is true only if the velocity v of the moving particle is much smaller. When the velocity v is much smaller than light c, then we can use this formula. Otherwise it means it is higher velocity can be higher than c, if but it is much less, means it is only few times less as compared to c, then we can't use this formula. Okay, it happens when the velocity of the particle is of the order 10 to the power 6 meter per second, or less than this, then this variation in mass is actually very small enough and mass can be considered to be constant. Okay, if the velocity is more than 10 to the power 6, means it is close to 10 to the power 7, then we cannot consider it that the mass is constant. Mass will change. Okay, so whether now is the rate of change of momentum when a force is applied to a moving body. Okay, what will happen? Its velocity will change either in the positive direction or in the negative direction. Means either it will increase or it will decrease, but it will change for sure. Okay, means when you accelerate, what will happen? When you move the accelerator, it will increase. What you are doing, you are applying force. When you apply the brakes, then what will happen? It will slow down. It will velocity will decrease. In the accelerating case, the velocity will increase. Okay, so when you apply force, the acceleration will change and the speed velocity will also change. Let a force F be applied on a body of mass m for time t, okay, due to which its velocity changes from u to v. Then the initial momentum of the body equal to mu, final momentum is equal to mv. Now the change in momentum in t second would be what? Mv minus mu. That will be equal to m whole into v minus u. Okay. Then we can find the rate of change by when we divide the change in momentum by time. We'll get the formula. Rate of change of momentum. That will be m whole into v minus u by t. But we know that acceleration is equal to change in velocity by time. And in this case, change in velocity is v minus u and time is t. So when you use this formula, that is a equal to v minus u by t, we will get m into a. Okay, that is a very important formula. F is equal to ma, rate of change of momentum, and this we will derive it later. Okay, we will find f later. Now just don't remember it. Now it is just equal to rate of change of momentum is equal to ma. Just a second. Okay, now rate of change of momentum is equal to ma, that is mass into acceleration. This relation holds good when the mass of the body remains constant. Okay, when a force acts on a body, the rate of change of momentum is equal to the product of the mass of the body and the acceleration produced due to it due to that force. Okay, there is also alternative method in which in time del t, if its linear momentum changes by del p, then del p by del t is equal to del m into v by del t, that is m into del v by del t, and we know that del v by del t is equal to acceleration. So in that case we can find del p by del t is equal to ma equal to mass into acceleration. Okay, no, here del p by del t would be equal to mass into acceleration. Okay, rate of change of momentum. Now our important thing, what is the Newton's second law of motion? Okay, what a force changes the state of motion when it is applied on it. Okay, it means that the force produces acceleration in the body, that is the force is the cause of acceleration. You also saw when you apply the brakes, that is when you apply force, what will happen? The body retards, that is the body means the acceleration is on a decreasing plane, decreasing. When you accelerate, the acceleration increases, means the velocity increases. When retardation, the velocity decreases. Okay, it is a common experience that if you push a tennis ball gently, the small acceleration is produced and it acquires a small velocity in a certain time. But if the same tennis ball is pushed hard, a large acceleration is produced in it and it acquires a large velocity in the same time interval. Okay, thus the magnitude of two forces can be compared by measuring the accelerations produced by them. Okay, if force F1 produces an acceleration of 5 meter per second square and if force F2 produces a acceleration of 10 meter per second square, then the magnitude of the force F is 2 times the force F1. Okay, force F2 is 2 times the magnitude of force. Experimentally, Newton found that acceleration produced in body is directly proportional to the force. Okay, what did Newton found? That F is directly proportional to A. Okay, on the basis of his experiments, Newton concluded that the acceleration produced in body in a given the acceleration produced in a body of a given mass is directly proportional to the force applied on it. Okay,